my modular test rack is filling up quite nicely. It has been a while since I published some new videos. A few reasons for that. One of the reasons is that I designed a lot of CB related projects, and you can see those in my previous videos. And it took me about almost a year to get those completed and out of the way. And second reason is taxes. So I'm in Belgium, in Europe, and last year our government decided to add some taxes on packages coming from outside the European Union. It was about €2, but not per package, but per custom code. So you have multiple things in one shipment. It can apply multiple times. Okay, that will increase the cost for our hobby, but that was not the biggest problem. The way it was written out was that the Belgian Postal Office would handle that, and they have about €18 handling fee. So they didn't think that through, probably. So which means our package would be minimum of €20 extra, which is crazy. And then the European government want to do the same thing in a few years' time. And they now decided to move the date forward to July. So that was the reason why our government dropped their proposal, because the European proposal was coming, which means from July on, everything that I get from PC boards and some components, even from the US, from Mouser, GLC PCB, everything will be more expensive anyway. And we're looking at a tax and a handling fee and a minimum of €5 per shipment, I believe. So that will increase our costs. So I had a bit of a deadline, and my goal was to design as much modules as possible, get the boards done, get the components in, and then in a later stage get working on completing everything, finishing the modules, writing the software. So that was work in progress for several months now. So when I completed that, I have 1, 2, 3, 4, 5, 6 modules done in that time. 2 of them are now finished, and that will be this video and the next video. I have 3 more that I'm working on, 4 more that I'm working on. But first I'm gonna complete my tube play amplifier, which is on my bench since a couple of years, was interrupted by some other things. So I have 10 more projects that I have worked on that I want to complete first before I move on to the next modules. So this video will be about the test source. First I'm gonna pop it on. I'll also power on my signal tracer. I'm going to use that as an amplifier for the testing. It's now connected to the Wi-Fi. It's configuring the SD card and the MP3 player. If I'm working on an amplifier, I want to run a sine wave through it to check the waveforms, check for clipping or signal tracing. I have an ISHP signal generator, but that is a fan that makes a lot of noise. So also want to run some music through it, see how it sounds. I can do that with my CD player. I can use a Chromecast, but it needs a lot of stuff. So this is all things combined into one. So standard, it is muted. I can go to the menu. I can go to sine mode, and that will turn on a sine wave. I can adjust roughly here and the output potentiometer as well. Change frequency. I'll just mute that for a moment. So a simple sine wave, not very precise, but accurate enough to do a few measurements and signal tracing as well. The sine wave is generated by the ESP32 itself. I have Bluetooth mode, which means I have a Bluetooth module inside, so I can connect with my iPad to this Bluetooth module and play some music. Another one is the SD mode, and then it will go to the SD card. And I have a bunch of songs up here. I can do MP3 of FLAC. Not gonna play much because of otherwise I get slapped with copyright issues. There are some files that have a sweep as well. So I have, for example, exponential sweep in here. So I can also set it to auto repeat. I can skip forward. Yeah, it's not so much a skip for the moment. I can skip forward if I want to, or backwards. I can pause it. I can start, restart. I can play. I can adjust the sound. So that's the SD player. And in radio mode, I can go to some preset radio stations and play those. I have 10 that I can program. I'll get back to menu. So if I'm at boot pushing a couple of buttons, then I'm going into a configuration mode. I get a Wi-Fi portal and I can set the parameters for the Wi-Fi and also the internet stations. If I hold the left button on power on, I get into a configuration mode where I can upload MP3 files to the SD player. So without having to take the SD card out of the module, I can write songs to it, and I have in the menu an option to delete files. So that's basically the test source, sine wave, music from the SD card, music from radio station, or just, yeah, muted, just nothing. Look at the test source module. Usual display, rotary encoders, stereo potentiometer for the output, left and right output. On the inside, ESP32. In this case, we use the W Rover board because we needed the PS RAM for the streaming. SD card reader, Bluetooth module, MP3 player, a multiplexer, 4x2, dual. So I can select ground, I can select the sine wave output, I can select the Bluetooth, or I can select the MP3 player. A little bit of a power supply to enable the power to these modules. Level shifter, because this one works on 5 volt. A few words on the SD card reader. SD card itself is 3.3 volt level, ESP32 as well, so they can communicate directly. This is just the minimum design of SD card reader. There are some other ones. They have a 5 volt to 3 volt regulator on board. They have some level shifters as well. So these boards can work with 5 volt or 3.3 volts, but they have a design flaw in them. So the level shifter does not restate when the module is not chip enabled. So that will conflict with other devices on the same bus. And in this case, we have 3 SPI devices on the same bus. So I cannot use that type of module here. So that's why I have this one that has no level shifters and does not conflict. The MP3 player module, it can also play FLAC and some other formats. In the past I have worked with these modules, the same chip, the VS1053, but these boards have a bit of a problem. So you have no header connector for the output, and the output's only via the jack, and it's configured that it's only useful for a headphone, which means the common is not ground, but it's on an offset level. So if you connect this to an amplifier, you will get some strange noises. And there is a solution for that, and that is to use these isolation transformers. But then you have a bulky design and you don't have a proper connection and need to use a jack, so that's not a good design to use with an amplifier. So I made my own design, and this is it, plug-in board with everything on a connector and fully configured for the amplifier output and not the headphone amplifier.